Alright, so having studied the definition of least common multiple and found a way to compute least common multiple, we now move on to finding least common multiple by using the fundamental theorem of arithmetic. So again, we express both a and b as a product of the prime numbers, where the prime numbers are arranged in the ascending order and the powers are the non-negative numbers a sub I and b sub I, where a sub I are the powers in the expansion of a and b sub I, b1, b2 and b sub n are the powers in the expansion of b. Alright, so with this definition, we have least common multiple equal to the first prime number raised to the power the largest of the two powers. So the maximum of a1 and b1 will give us the required power of p1 in the least common multiple. Okay. Similarly, the power of p2 will be obtained by taking the maximum between the powers of p2 here and the powers of p2 here. Okay. And so on, we go till the last prime number in the factorization of a and b. Let's look at a couple of examples to understand this concept. So here we have two integers, 60 and 54, and we know how to find their prime factorization is given as follows. This is similar, actually the same example as we had for the greatest common divisor. In the case of the greatest common divisor, we picked the smaller number to constitute the greatest common divisor. But in case of the least common multiple, we pick the largest power. Okay, in this case, between 1 and 2 we choose 2, between 1 and 3 we choose 3. Okay, and between 0 and 1 we pick 1 as the power to be used in computing the least common multiple. And when we multiply these numbers together, we get the least common multiple of 60 and 54.